Hello guys, welcome to another edition of our studies on linear equations and inequalities. Today we are studying graphical solution to systems of linear inequalities, and we will deal with the set of inequalities involving the same variables. Good. What is a system of linear inequalities? It is a set of inequalities involving the same variable. So what it means is that we are going to have two or more inequalities with the same variables. It can be x and y or a or and b. Good. So here the solution is the overlapping region that satisfies all inequalities. So the solution will be the same as finding the solution of inequalities involving two variables, where we have to know the region that satisfies such inequalities. Then the main thing here is we are going to use graphical methods. So why do we have to use graphical methods? It helps us to visualize all possible solutions. It also helps us to identify the feasible region, that is the acceptable region that satisfies all the inequalities. And it is also important for real world application like optimization. We are going to learn something about optimization, and to be sincere with you, you will get to understand the reason why we study this particular topic using graphical method. Now let's move on to the steps to solve a system of inequalities graphically. Here, the first one is we should solve each inequality for y. Why? Because we've learned on how to draw or solve for inequality involving two variables. So you are supposed to remove the inequality sign, then represent it with equal to, then you solve or you make y the subject. That will help you to draw your borderline. So to draw the borderline, you need to find the intercept of each boundary line. So you are going to find the intercept on the x and the y axis together with some points. Then use the point to draw your straight lines for each respective linear inequality. After that, the straight line is supposed to be a solid or a dashed line. They are all accepted. Then use test point to determine shading. So after drawing all your inequalities, you are going to realize that the lines are intersecting themselves to form a unique shape. Good. So you are going to get a spaces, whether outside the shape, inside the shape, or below, up, or whatever the space might be. You are going to use or take up points from each respective space to text and see if such points satisfies all the inequality. So the solution where all shaded regions overlap, that means the solution where your test, that is the point that you took, satisfies all the inequality. That's the meaning of the overlapping. It means that that particular space becomes your solution or your answer. So let's see as a simple example in this form. We have to define the system for you. So the system for this particular example has been defined graphically in this form, that we are supposed to know this particular inequality. So we have the inequality x plus 2y greater than or equal to 8. We have inequality x plus y less than or equal to 12. Then x greater than or equal to 0, y greater than or equal to 0. So what we have to do, we need to convert all these inequality into an equation form with the use of equal to. So look at how it has been arranged here. The inequality signs are off, then equal to sign have been replaced with them. So here we are going to make y the subject and draw each respective inequality line or uh, line, yes, and the line will serve as the borderline for each respective inequality. So look at, we have x plus 2y equal to 8 here. These are the x and y intercept, and here too x plus y equal to 12. These are the x axis. This is what intercept on both the x axis and the y axis. The same thing applies to this one, intercept on both the x axis and the y axis. Remember, on the y-axis x is 0, and on the x-axis y is 0. So text a point after you plot this graph. You see the graph, then use a test 0, 0 to test the point to see if it satisfies the inequality. So when you put 0, 0 here, we are going to get 0, which is not greater than 8. So it means that 0, 0 failed the test for this particular inequality. Then this one too, it passed. But now we continue at this section. We know that the point 0, 0 does not satisfy this inequality. So this is the graph of x plus 2y equal to 8. So this point does not satisfy the inequality. It means that the solution for this particular line is above the graph, above this line. Good. Then the point 0, 0 here also satisfy this inequality. So this is it. The point 0, 0 satisfy this inequality. So x plus y is less than or equal to 12. So in that case, it means that the solution for this graph is below the graph. It means that this one is above, this one is below. So they are trying to meet, they are meeting at a certain point. Then look at the y-axis here, look at the x-axis here. It means we are going to get some space. The space will be area 1, area 2, and area 3, or space 1, space 2, and space 3. So when you look at space 1, when you take any point, you are going to realize that the point at space 1 doesn't satisfy all the inequality. When you look at the space 3, you can take any point from space 3, and you are going to realize that the point at this section only satisfies one particular line or one particular inequality. So it means that the space 3 is also out of the expression. Look at the space 2. Take any point at space 2. When you substitute them in each of the inequalities, you are going to realize that all that particular point satisfies both the x plus y less than or equal to 12 and x plus 2y greater than or equal to 8, which means that the space 2 here, the area 2 here, becomes the solution for this particular inequality. So that is the solution that we have here. So that is the reason why this space has been shaded for you, because when you take the point A, the space 1, which is here, we can use 1 1 1 1 is here, good, and test. The moment you test, you are going to realize that this one does not satisfy, but this one satisfies. So we can't choose this space as the answer, because the space have to satisfy all the inequalities. So look at space 2. We can take 5 5, for example. You are going to realize that it satisfies here, it also satisfies here, because 15 will be greater than 8, then 10 will also be less than or equal to 12. It means that the 0.55 satisfy this particular inequalities, the two of the inequalities. You just substitute s here, substitute y here, find the answer, and it will be 15. The same, repeat the same process for this particular inequality, and the answer will be 10. And it means that we are getting 15 greater than or equal to 8, 10 less than or equal to 12, which satisfies both inequalities, both the inequalities. So it means that space 2 is our solution. Look at space 3. We can take 10 10, and it only satisfies the first one, it doesn't satisfy the second one. So our feasible solution will be this particular area which has been shaded. So let's look at example 2. The same process, repeat the same process here, turn them to equation, then plot the graph, respectively. After that, we are going to take points to see if they satisfy the inequality. So for this one, 0 0 satisfy both inequalities, which means that after plotting the graph, all of them are going to be on this particular space. We shade this space. That is, the blue line is the inequality or the graph of 2x plus 3y equal to 8. And the red line is the graph of x minus 2y equal to 3. Then we have the x-axis and the y-axis. So they are forming this particular shape. These are the point of meeting 1, 2, 3, 4. So there is a polygon shape. So here we are shaded here because the point 0 0 satisfy both of the inequalities. So it means that the space, which is this particular space, becomes our solution for this particular inequality expressions. So the feasible region is in the first quadrant where all constraints overlaps. So here, this is the point of the constraint, the point 1, 2, 3, 4, the points here. So this space is the space that we need to shade to identify the feasible solution. So all the points here satisfy this particular inequality. So they are the range of solution for this inequality. Good. So we can have a real world application and class activity. We use this one in optimization and budgeting and production, and to find a feasible region to satisfy the constraints. So we can use this one in optimization. That is what we are going to study in our next meeting, and please prepare well. It's very interesting. So coming to our next meeting, make sure you get to know this particular aspect of our studies. So try this activity and send us your feedback for us to look at it for you. The summary of our studies is about to plot each inequality step by step. We use intercept and the test point to identify the feasible regions. The feasible regions equal to all constraints that satisfies the inequality. So it means that anytime you shade the portion that you shade will means that all the points in that particular portion satisfies the inequalities. So it is useful in planning, budgeting, and resource allocation. And we use this in optimization. Our next meeting will be very interesting. I can't wait to see you. Thank you. And keep learning with Roland High School Math Room, and your mathematics education is shaped to the right format. God bless you.